Hi there, grade 5. It's me again, your natural sciences teacher. I hope you are all well. And warm. It's very cold here in Cape Town this morning. I've got a nice cup of tea in front of me for our lesson today. And I don't know about you, but it's definitely getting harder to get out of bed in the mornings. It's darker and colder and misty. And I think I'm also starting to feel that the novelty of being able to be at home and wear my pajamas as much as I like is wearing off slightly, and I just want to be back at school with my class and see my colleagues, and I'm sure you miss your friends too. But it won't last forever, and the great news is that you have us here at WorksheetCloud to keep you up to date and make sure that you've got a head start for when you do get back into that classroom. So, with that in mind, we're going to continue today our study of energy and change. Now, in our last few lessons, we've looked at what energy is, the different forms of energy, and how energy can be transferred from one form into another. We then looked at non-renewable and renewable forms of energy and explored what fossil fuels are and the advantages and disadvantages of both renewable and non-renewable energy. So what are we going to do today? Well, let's get started and let's find out. A reminder, as always, of our email address, grade5@worksheetcloud.com. We love hearing from you here at WorksheetCloud. Please don't forget to drop us a mail when and if you can. Okay, so rather than me just telling you what we're going to be looking at today, I thought I'd see if you could figure it out. Have a look at the pictures on the screen in front of you and think about what makes each item work. And what is that thing? Because they all have it in common. So maybe you wish to pause your video now and have a very close look. Don't be fooled by this one here. Look very closely and see if you can tell me what they all have in common. Well, that's right. They are all being powered by electricity. Here, I obviously have a plug socket with a plug in it. This is a busy street in Japan, and you can see all the electric cables coming down. I've got the light bulbs, a hairdryer, washing machine, and as I said, don't be fooled by this because you may have thought it was pumping in petrol, but this is actually an electric powered car. So, what are we doing today? We are going to learn about how electricity is generated. How do we make electricity? And some vocabulary that I'm going to introduce you to are transformer, generator, current, conductors and insulators. Now you hopefully should remember that from our work on material and matter. Alternate current and direct current. So as I said a minute ago, all the items on that previous slide were powered by electricity. So you may wish to have a think now about what you already know about electricity. You could perhaps create a mind map in your book or your piece of paper that you have in front of you, showing what you already know about the topic. And here are some guiding questions that you could use to structure that mind map. Where do you think electricity comes from? How do switches work? What materials allow electricity to flow through them? Tongue twister there. And can you think of some items that use electricity to work? Well, but you can't use any of the ones that I put on the previous slide. That's cheating. So pause your video if you would like to and have a little think and see if you can come up with some answers to those prompts. Okay, so let's go through now our work today, and then at the end of it you can come back to that mind map and hopefully build on it and extend your knowledge. So, what is electricity? Well, actually electricity is a naturally occurring thing. When we refer to electricity, we usually mean an electrical current. And that means that it flows, a current, not a current like you have a currant cake, not something you find in your mum's cupboard, but a current is something where there is a flow of an electrical charge. So here's some examples of some naturally occurring electrical charges. Lightning, I love this picture. Static electricity. Who's ever had that? You know, sometimes when I close my car door, I get a little electric shock from it, or I put on one of my jumpers, my hair will stand up on end like that. Not quite so bad, but... and also there are things living such as electric eels that have what we call bioelectricity. Now, remember yesterday I told you when we looked at biofuels, the word bio means living. So bioelectricity, it is a living thing that is producing electricity. And there are many other examples that I could talk to you about right now. For example, just one off the top of my head is your own brain. Your brain is firing off little electrical currents, little electrical signals all the time, not every second, more than every second, to make your body work and to make sure that you stay alive. Your nerve endings use electrical currents to get messages from the body to the brain, and so on and so forth. So electricity is a naturally occurring thing. Okay, so let's have a look at my picture here. Here is a picture of a bedroom, might even be yours. How many items can you see in the room that require electricity to work? You may wish to pause your video to find them. Well, I can spot at least 10. We've got the electric guitar, the hairdryer, the laptop, the light. This might be a night light, and even if it has batteries, batteries are a charge. They store a chemical energy source of electricity. The television, the light of the room, the lamp above the bed, a tablet computer or iPad. Here we have a mobile phone on charge. So you get the idea. Have a little look around the room you're currently in, and you'll see how prolific electrical items are in our homes today. So we have just discussed how electricity occurs naturally in lightning strikes and in our bodies, but scientists over many years have managed to create electricity and generate electricity. That's what we say generate it. So we actually call electricity a secondary energy source, which means that you have to use a primary source in order to generate and create electricity. But electricity, if you remember back to our lesson a couple of weeks ago, is a very useful source of energy for humans because it can be easily converted into heat, sound, light, and lots of other energy types. Now, of those electrical items that you've looked around your own room and in the one of the picture I just shown you, there are two ways that we get electricity to those items in our homes. The first one is mains electricity. So that is anything where you have to plug it in. There's usually a cable and a plug that you have to put into a plug socket in the wall. And that comes from, in South Africa, a company called Eskom. So we have mains electricity, and that current is called an alternating current. It's AC for short. Otherwise, you might have battery powered items that still use electricity, and batteries generate a direct current, and we call that DC. So you may, I don't know if you know this, but maybe your parents definitely will. There's a very famous band and their name was AC/DC, and now you know where that comes from. The alternating current as opposed to the direct current, AC/DC. Have a little look, maybe you can YouTube them. So, as I've said before, electricity is a secondary energy source. We actually have to burn or use other sources in order to generate it. So, have a little look at the slide in front of you. I've written an energy source is a way of powering something. Electricity is a secondary energy source. This means it is made from a primary source of energy. And here, and should look very familiar to you from our last couple of lessons, are some examples of primary energy sources. So obviously coal, oil, natural gas. You should all be able to group those together as fossil fuels, that's right. And wind power and solar power, those being renewable energy sources. So since electricity is a secondary source of energy, it needs to be generated. And there's different ways we do that based on the primary energy source we are using. So let's have a little quick look at how we generate electricity from those primary sources. Well, fossil fuels, the first group, we burn them. We burn them to produce heat, often to boil water, and the steam that comes off the water spins a turbine to produce electricity. I will show you a diagram of this a little later in our lesson. Nuclear energy can also be used. Nuclear energy is created with atoms when we split or combine them, and that creates heat when that happens, and that can be used to heat water to turn a turbine and so on and so forth. Hydro and wind, water in dams or wind turning windmills at wind farms can both generate electricity. Solar, remember the sun shines on special panels and those convert energy into electricity. Or geothermal. So geothermal, hopefully you remember we analysed this word the other day, geo from geography meaning earth and thermal meaning heat. So geothermal is heat from the earth which can then be converted into electricity. So, little bit of a recap as to what we covered in our previous lessons, whilst also learning about electricity. Can you match the source, the primary source of energy, to its correct name from the pictures? So have a little look, and again, you're more than welcome to pause your video if you'd like to, but which pictures do you think represents which form of primary energy source? Okay, I hope you did that, because now I'm going to show you the answers. There you go. This one obviously illustrates the fossil fuels of coal, oil and gas. This actually is a universal symbol for atoms, nuclear. This shows geothermal. As you can see, it's got pipes going deep under the ground in order to get the heat out. We have the hydro and the wind, and then this house has got solar panels on the side of it. So we've really briefly looked at all those different ways that we can generate electricity. As I said, in a little while, I'm going to show you a little animation of how it works. But just so you know, most of our electricity in South Africa does come still from the use of burning fossil fuels. And although they are non-renewable, and although they do produce some nasty gases that go up into our atmosphere, they are also relatively cheap. And that makes electricity affordable for houses. So again, remember there are always advantages and disadvantages to every method. Okay, so we are now back to that favourite site of mine that I introduced you to at the end of yesterday's lesson, which is the Children's University of Manchester. And again, please do feel free to go and have a little look at this free site in your own time. It is a UK-based site, but it's available everywhere, and it's got lots of topics, not only science, there's some history and some English and some maths as well. Anyway, we are interested in electricity, and I could not find a better way of explaining to you how we make electricity as a secondary energy source, not, remember, naturally occurring. So here it says electricity can be made using a very simple generator like this. So what we've got is we've got a magnet, and around the magnet we've got coils of wire. So as we turn the magnet around the coil, electricity is made within the wire. Okay, and if we connect a bulb to the magnet, the bulb will light up, because now we have produced a electrical current, and that current can flow through the wire and through the bulb. But of course, that's not going to help us when we need to power millions of homes across South Africa. So to make enough electricity for everyone, we have to use very large generators, and we make these generators turn in different ways. So here is an example of oil, coal or gas powered stations. So this is what is most prevalent making our electricity in South Africa. We burn the coal or the fuel here, and that in turn warms water, creates steam, and the steam then turns the turbine, which turns the generator to make electricity. With hydroelectric power, there's lots of water which is dropped onto a wheel, which makes a turbine turn, which makes the generator spin. With nuclear, and we do have a nuclear power stations in South Africa. There's one in the Western Cape, Koeberg, on the Western, it is in the Western Cape. Sorry, my knowledge of geography is shocking. But yes, so we do have one. And nuclear power stations use radioactive fuels such as uranium. Uranium, as I said, produces heat, which boils the water, which makes steam to turn the turbine, and so on and so forth. You can have biomass power stations burning fuel from trees, shrubs, even animal poo. And that again would produce enough heat to turn the turbine, to boil the water, which turns the turbine. And as I said earlier, geothermal, we don't need to burn anything because the geothermal says the heat of the earth, so there's already heat there. Engineers drill down into the earth, into the reservoirs of water beneath the earth's surface. The heat comes up, spins the turbine, which makes the generator turn. Solar panels. Now, these work slightly different. All of those ones are turning a turbine, and this one doesn't. So the energy of sunlight can be used to make electricity because the solar cells in a solar panel, and there is a special name, they're called photovoltaic cells. So excuse me, I'm really struggling with my words today. Usually contain silicon, and those produce electricity when the sunlight hits them. And then obviously there's tidal turbines that we can have underneath the water, and those, again, as the tide moves, it turns the turbine, which makes the generator turn. And then obviously we have wind turbines operating in exactly the same manner as the tidal, but this time obviously the wind is blowing. So now we have the generator spinning. How does that electricity that is being generated reach our homes? So here on the screen I have this one's obviously showing a wind turbine, but remember this could be a power station, a coal burning power station, or a nuclear power station, or a geothermal. It could be any one of those primary sources being used to spin the turbine to make the generator move. So here the electricity from the generator travels along underground power lines into what we call a substation. And you may have seen these if you're driving along main roads, you can sometimes see them. Inside a substation, a transformer changes the electricity into a higher voltage, collects it and changes it into a higher voltage, and that makes it easier and more efficient to move it long distances. And we move it long distances using overhead cables. And who's ever seen these pylons when they're on long drives? Probably, yeah. And those then reach another transformer, and that transformer takes that high voltage electricity and makes it into lower voltage so that it can be distributed and used safely in our houses. Now, please do remember that all of these things, especially the overhead lines and the power cables, are exceptionally dangerous and you should never go near them. But we will learn more about electrical safety in our next lesson. And that then reaches into your homes. Okay, quiz time. Which of these is used to make electricity? Well done, it is a generator. Which of these is used to turn the generator? It is a turbine. Obviously, except if you're using solar power, that doesn't have a turbine. Which of these provide energy to turn the turbine? Sun, wind, water, coal, wind, biomass, geothermal, sun, nuclear. Well, I'm telling you now it's got to be B, because the sun, remember, solar power does not turn a turbine. Get clapped every time we get something right. It's quite fun, hey? What is the fuel used in nuclear power stations called? It is uranium. Oh, here's a toughie. I only mentioned it once and I stumbled over it when I said it. What is the correct name for a solar cell? Photovoltaic. I still can't say it. What is the gearbox used for in a wind turbine? Now, we didn't actually go over this, but see if you can have a guess. It is to increase the speed. And what is used to increase the voltage of electricity? This was one of our words. In fact, I think it was our first word in our vocab list. Transformer. And remember, what is used to decrease the voltage of the electricity to make it safer in our homes, or safer? No electricity is safe, but safer. Again, it is a transformer. Well done. So now you know, AC/DC isn't just a popular band that your parents listen to, it's alternating and direct current. And transformers are not just robots in disguise. They are essential in making sure that we get electricity safely to our houses. Okay, so that's enough for today's lesson. Tomorrow's lesson, we are going to look at electrical safety and how to stay safe when using electrical appliances around your home. Have a lovely day further, grade 5s, and I will see you soon. Bye-bye.